Hi everyone, thanks for coming for our session today. My name is Diego Akeshi. I'm the engineering manager for SLES for SAP and HE extension at SUSE.
And I am Xavier Arbulu, software engineer as well in the SLES for SAP and HA team together with Diego.
Yeah, SUSE and SAP has a very long history of partnership, so it's completing to this year, 20 year of partnership. And we had, as you can see here, many of co-innovations and history around this partnership. Today we want to show you some of our new initiatives around automation and SAP landscape deployment that aims to really simplify this work. So before we go there, let me introduce a little bit more about what is SUSE Linux Enterprise Server for SAP applications and its capabilities. So the SUSE Linux Enterprise Server for SAP application is the SUSE platform that's really optimized for SAP operations. This is the preferred operating system for SAP HANA and is also the development platform for the in-memory database provided by SAP. But it's a composition of services and software that's offered in a single package. So a part of some services like extended service pack overlap support, specific SAP tooling like SAP Tune, cluster tools, system replication resource agents. We are including now on the next release, on the next version that will be SLE 15 SP2, capabilities around SAP monitoring and SAP automation. So full SAP landscape automation. That's the focus of our talk today. And what the SUSE Linux Enterprise Server can do for my SAP landscape. So especially about the HA capabilities. So SLES for SAP application brings inside bundled all the HA extension on it, so out of the box, and then it can make your SAP landscape fully high available. So it covers S for HANA and SAP NetWeaver HA capabilities. So here's a diagram of some options that you have. So you can have a full AS, CS, and ERS fully automated failover using the PCMaker, Core Sync, and our resource agents included on the product. We also offer fully automation for the SAP HANA system replication capabilities. So it shortens the recovery times and in many different scenarios. So here we have some examples about performance optimized, cost optimized, the chain technology, and also the scale out scenario. Also important to mention that this capability is not only available for on-premises deployments, but the same capabilities with very similar user experience is available also for the major public cloud providers.
Okay, and after saying that, let's go to the funny part of the session where we are going to talk about automation. And most importantly, before beginning, why we need automation, specifically in SAP landscapes. So which are the major issues that we just face usually when we want to create SAP environments? We can just list some of them here. The first and the major one is that the whole deployment takes a lot of effort. The SAP landscape is a multi-machine environment where we have several machines. You have already seen some of the diagrams before. So we can have the database, we can have NetWeaver, we can add some more high available storage options like DRBD. So deploying everything is quite difficult, and if you need to do it manually, you need to follow a lot of operations that, talking about the second point, can bring errors. Usually you need to run a lot of actions that are similar in all of the machines, but they can have specific operations in each of them. So when you do it manually, you can have errors there. So this is something that we want to simplify and improve in the automated deployments. The third one is about the length of the deployment. Usually when you want to start using SAP, you want to do a lot of deployments for testing, for QA, for pre-production, etc. So deploying all of them takes a lot of time, even months. So what we have been seeing is that with automated deployments, you can reduce a lot your time for having an initial design of your architecture to have something working. Finally, in top of SAP, as we are adding the cluster, the HA cluster functionalities, it just makes more difficult the deployment. So having everything automated even here will reduce all of the steps that you need to follow. So this is just a small description about the issues and the vision we have at SUSE about what we want to do with our data centers. So right now we have a lot of best practices guides that you need to follow in order to install your machines. So for that, you need to go one by one and install them manually. This is what we call mode 1. So the next step or the evolution would be mode 1.5, where we are going to deploy all of the machines in our data centers automatically. And this is more important when we are just entering in a moment where cloud providers and cloud data centers are being used more and more. So having everything automated it's an important thing. Now finally, this is not the specific topic about this session, but we have the day 2, so the monitoring capabilities. We want to just make sure that everything is working properly. We want to troubleshoot any issue. So for that, our colleagues in our team are going to just give all the session about monitoring capabilities of SLES for SAP and HA, so just keep tuned. So let's go to talk about Terraform and Salt, that are the 2 major pieces of our automated solution. Both are open sourced and they have a really big community behind, so that's why we are just using them. So talking about Terraform, it has a lot of benefits that can bring a tool that is based in a infrastructure as a code solution. I will talk more about that later. So with Terraform, we have the option to build, change, and version our infrastructure. So that's really important because, as you know, now we are going to deploy more environments every day. So having the option to make it easy and version it, it's really interesting because we know which is the progression of our deployments. The second important thing about Terraform is that already supports a lot of providers, the most important ones in the cloud, like AWS, Azure, and Google Cloud, but it supports as well libvirt to work in KVM hypervisors, so that's really important. Other important thing about Terraform is that it can manage almost everything on the providers, starting for high-level components such machines and network to go to lower levels like routing tables, DNS entries, etc., etc., etc. So it's extremely powerful, and you can just configure your deployments really customize it. And finally, coming back to infrastructure as a code, the big benefits of Terraform is that we can define all of this infrastructure in code with a quite simple syntax, and this will be just translated to the actual infrastructure. So it's quite interesting for developers and DevOps to know that they can just change things in code, and this will be replicated all the times in the same way. And about Salt, if Terraform was or is used to create the infrastructure to all the elements, Salt is used to configure the machines. So Salt is a configuration management system that gives you the option to provision the machines, install packages, configure files, start daemons, etc., 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 with configuring states. We are going to talk about that later. One of the most important things about Salt is that it's distributed. This means that usually you can run Salt in a master minion architecture where you have all of the information in the master, so you can just give the operations and the tasks to the minions, so they will be just executed there remotely. Finally, other important thing about Salt is that it has already a big set of standards implemented. It's open source. It has a really big community behind, so we can just leverage all of these functionalities in our project. And yeah, if we take both of them, we have the whole solution, right? So we can create the infrastructure and we can configure the machines. One thing that I would like to mention is that both tools follow the rule of idempotency. This means that every time you run them, they will reach the same state, independently which is the starting point. So this is important to know because we want to assure that our deployments are always in the same state when they are finished. Other important point about the solution is that it's split in different blocks. One is for Salt, other is for Terraform, so they can be reused. And even inside them, different components of the deployment are split in different modules. So for example, you can just deploy HANA or only NetWeaver, and you can play with that. And finally, as these two tools are being used by SUSE, we can leverage them and use them in other solutions like SUSE Manager, etc. So right now we have an open source project that is totally available for everyone, where you can find the deployment in the next cloud providers that are Azure, Amazon Web Services, Google Cloud Platform, and Libvirt. And this is what it deploys. As you know, SAP landscapes are quite difficult. We have NetWeaver, we have HANA, we have the storage, and later we have all of the support machine that needs to be just running. For example, here you can see in the top left box, the SAP HANA cluster that it's just composed by two machines that configure the system replication in that sense. And on top of that, we can configure PageMaker. And we have the same for DRBD or NFS service cluster with two machines. And finally, in the top right corner, we have S/4HANA or NetWeaver, in this case with 4 machines, providing high available message server as well with the ASCS and ERS. The idea behind that is this is totally configurable. You don't really need to just configure everything. You can create only SAP HANA cluster, even single HANA node, etc. So it has a lot of customization available. So here you can see, for example, what high availability provides. Usually we create a virtual IP address in each of the clusters that it's moved across the machines that are serving their major component. For example, in the case of SAP HANA cluster, obviously we are serving the database entry point. So the virtual IP address will be the IP used by NetWeaver in this case. But if something goes wrong and we need to just operate a failover and start serving in the second node, the virtual IP address just will move from node 1 to node 2. So NetWeaver can continue just operating as nothing happened. So this is what it's really important to understand. And coming back again to the cloud providers, all of them have different specific customization around SAP and the cluster itself. So the project tries to just encapsulate all of this, hide the complexity of the deployment, so each of the providers has its details. So for example, in Azure, we are going to configure the load balancer, or we are going to use different resource and phase agents that each of the provider needs, because obviously they are not the same. And this is the architecture. I am not going to go deeper here, but we just wanted to show you that all of the pieces are just usable independently. So we are offering the Terraform modules, the Salt functionalities that are split in execution modules, states, and formulas that can be used for by more advanced users. And on top of that as well, it can be integrated with other platforms like AutoJust, SUSE Manager, etc. So it's important to understand that it's not just a single scenario deployment, that you can just configure almost everything from scratch. And as well, in the project that I will show you later, we have split this into different logical boxes and steps. So here down we have the blue boxes that are already provided in our open source project that involve the creation of the infrastructure by Terraform and the initial host preparation. So that means that we are going to register to SUSE Customer Center, we are going to install some packages, etc. So this is available already in the GitHub project that I will show you later. And finally, we have two other layers that are the SAP installation and the HA cluster configuration that are already provided in the latest version of SLES in SLES 50 SP2, specifically in SLES for SAP, where you can find the Salt formulas to run the configuration of SAP and HA. So here you can see which are the functionalities that we provide in each of the packages or components. So how we can just run the project? I will show you that it's quite simple. So these are the steps that we need to follow. Later I will do a demo showing how easy it is. Well, it's easy, but it has a lot of configuration, so it has a lot of advanced use cases. But this would be like the quickest start that if I want to run the project as a beginner. So obviously each of the providers have different options to iterate with the IP options that provide them. For example, Azure needs to have the Azure client installed in your machine. So for that, we will need to install the package and obviously authenticate our user running AES login. This will just open some browser tabs, and we will just need to authenticate ourselves to give Terraform the option to create everything. Later, obviously, we will need to just download the Git project. And in our case, as we are going to use Azure, we are going to enter in the Azure folder that we provide. We have the same folder for AWS, Google Cloud, and Libvirt. Later, this is the most important point right now. We need to configure our deployment. For that, Terraform provides the option to have configuration files that are based in key value syntax. So there we can configure a lot of things that I will show you later some options. And finally, we will need to run some operations to create SSH keys, etc., that are used to make the cluster able to communicate between the nodes. This is another important point, the pillar files. The pillar files are Salt native options to configure the deployment. So they can be used for really advanced configuration. Right now, we are providing some templates that just create a scenario based in the Terraform input. But for more advanced users, you can just tune the pillar files in order to make the configuration more advanced. With that, for example, you can configure if you want to enable system replication in HANA, change different passwords, change a lot of things. So for advanced users, it's really interesting to understand how they work. But as this is quite extended explanation, it's not be covered in this session. And finally, yes, we need to run the Terraform options. So it's quite straightforward. Usually we are going to create a workspace because the deployment uses this information in order to create specific deployments. And finally, we only need to just Terraform init, plan, and apply. And this will start operation where all of the resources are created. Finally, when the deployment is not needed anymore, we can just destroy, and Terraform will only touch the resources that were created by him. So any other resources that are not belonging to Terraform will stay in place. So that's quite a safe movement. And that's it. After explaining all of this, let's go with the demo, and I will show you some steps where you can see how we can use the project. Right now I'm sharing the project in GitHub that we have because I want to show you how is the documentation. So this is the main project, open source project that I was mentioning before, where we have the Terraform and the operating system configuration. Here you can just go to different providers and just find the information. You can find everything related how to use the project here. Besides that, we are providing the templates that I mentioned before. So this is how they look like. Usually they are created as Terraform tf-vars example, and they are key value based files. So here we can define a lot of things. For example, we can define in Azure the HANA virtual machine size. We can define how many HANA machines we want, the Azure region, which is the image of our SLES for SAP versions, etc., etc., etc. It has a lot of customization, but it has a lot of default values as well. So you can run the configuration as a quick start, okay? So now I will run some commands and show you how it works. Actually, I am going to run all of the commands that I exposed before in the previous slides. So here I have my console. So Diego, is the font size okay? I guess that I can run it, right? Okay, so here I
Yeah,
already have the
it's
project
okay.
downloaded. Okay, thank you. And I am ready in the Azure project, okay? So as I was exposing, we don't need to do much. We need to just configure the tf-vars file. As I was exposing before, we are going to change everything, and we are just going to remove the example suffix, okay? So finally, we would have the Terraform tf-var file. So I have already had this file configured for me because it has some secrets, but you should do the same. Later, we are going to create the SSH keys. So for that, we are going to create the folder. We are going to create the keys. It's important to know that the keys must be passwordless, so just skip this option. And finally, we need to copy the pilar files that we want to use. As I was mentioning before, the pilar files are the most advanced configuration entry points. So if you only want to run a quick start or easy deployment, take them from the automatic folder that is in the pilars examples in the same repository, so you don't need to just take care of a lot of configuration. And that's it. Finally, we should create our workspace to have an isolated environment. In this case, I am going to create SUSECON. And finally, I am going to initialize Terraform. This takes a bit of time because it needs to download things. And finally, I am going to apply the changes, okay? So I am not going to run the plan because it only outputs what is going to happen. It's like a dry run, so the auto approve is enough. So after doing that, Terraform will start running different operations. It will check if we have already some resources in place, and it will start creating many things. As you know, SAP deployments are quite heavy, so it takes a lot of time. So for example, if you want to deploy NetWeaver, it can take up to 3 hours. So when we have this finished, I already have a scenario deployed, so I can show you what is the result. So I am going to switch back to one that I have already created that is called Sharbulu. Okay, now I'm just using the other workspace. And if I run Terraform output, I can find here all of the information that provides the execution. For example, I can find which are the internal IP addresses of the HANA machines, the public IP addresses of cluster, of DRBD, of SCSI, etc. So you can see in the first execution that everything is being created. So with that, you would be on place. So now I will show you the final result of the deployment to see which are the things that are involved. Okay, going back here. So this is the account or the resource group that is created for Azure. So you can see that it creates a lot of things. So it creates different availability sets, a lot of disks, because for example, HANA requires to have logical volumes. It creates all of the networking, like load balancer for DRBD, HANA, NetWeaver, the network interfaces, the security group, the public IP addresses, and the virtual machines. So as you can see, if you need to just create all of this manually, it takes a lot of time, and Terraform and Salt makes everything for you. So when the deployment is finished, we will have 3 clusters if we decide to deploy HANA, DRBD, and NetWeaver. That looks like this. This is Hawk, the HA web console, where you can see which is the state of the clusters. So here you can see which are the resources that are created for each cluster. For example, this is the HANA cluster where we have the clones for SAP, we have the master SAP instance resource, we have the fencing mechanism that is SVG, etc. And we have other 2 clusters that are the DRBD cluster with other different resources that are configured specifically in this case for Azure. So if you just deploy AWS, you would have different resources. So that's as well important. And finally, we have NetWeaver. So we have the group for the ASCS and ERS. Everything done by Terraform and Salt. And additionally, the deployment project as well provides the option to deploy our monitoring solution that, as I mentioned before, will be explained in other session by your colleagues, where you can see which are the state of the clusters. For example, here we have a multi-cluster overview panel where you can see that everything is going fine. But we have as well other panels, for example, one for SAP HANA details, where we can see how HANA is behaving. Here, for example, we can find that we have some alerts that we should check out and find them, fix them, and other information about memory, disks, operations, etc. So this is as well available in the project. And that's it about the demo. So I will go back to the slides and give the word to Diego to the final conclusions. Okay, Diego, so the word is yours.
Thanks, Xavi. Well, let's talk about a bit about our future plans. So as you can see, and I hope some of you had the chance to see our session on the last SUSECON as well, we did a lot of progress on the automation, and some of new features were introduced, like NetWeaver S/4HANA. So our future plans is to keep moving forward. So we want to enable more SAP application scenarios. So for example, and eventually other SAP applications like SAP Solution Manager or SAP HANA scale-out scenario, and some other possibilities are in our backlog. But we also want to release and offer the part of Terraform scripts that right now is offered via GitHub as a SUSE offering with enterprise support. So we are discussing this internally and see how to do. But since SLE 15 SP1, you can already use Terraform from the public cloud module that's also available on SLES for SAP product. So Terraform as a tool is already supported by SUSE, and we want to support the project as well. We want to improve more the UX and even simplify even further the options we have. So feel free to visit our project and give feedback, especially on that topic, because the project is made for you, for the people that needs to deploy and use our tools. So we are pretty much interested to receive feedback on how we can improve on that area. Also, in the future, we are studying possibilities to leverage even more integration with SUSE products. So we already have integration with SUSE Manager coming on the next version of SLES for SAP, but extending this to other SUSE offerings like enterprise storage, the CAS platform, and others. So here are the links of all the projects that Chab presented that we discussed today. Hope you have time to visit there. Feel free to reach us there as well with issues, questions. Also, all of them include a lot of documentation that we aim that also simplify the onboarding on the usage there. So I know that the presentation here we didn't have time to cover all those topics, but hopefully the documentation there helps you as well to cover the many different scenarios that are available. And then also some other links for our best practice that inspired all this project. So you can also get more feedback and more insights about where and why the project cover and take some decisions around how to configure the machines in a certain way. This is also the base from where we automated the project. And then with that, I would like to thank you all for watching our session. I hope you enjoyed, and feel free to leave your comment and send back some feedback about the project.